Hi everyone, welcome back. Today we are going to see an important topic in data analytics, which is binary classification. I am Priyadashni from Department of CSE SNS institutions, and by end of the session you clearly understand how we can teach machines to make yes or no type decisions like spam or not spam, fraud or genuine, and so on. Before we get started, here's a quick icebreaker. Can you think of a real world example of classification that you see daily? Maybe your Gmail automatically separating spam from your inbox, or your phone unlocking your face correctly. That is also a classification. We actually use classification models more often than we realize. Next is learning objective. So, what we are going to learn today? First, we will understand the binary. Binary classification. Then we will look into few real-world examples. Okay, and finally we explore some popular algorithms like logistic regressions, decision tree, and naive-Bayes algorithm, and so on, and evaluate how these models perform. By end of the session, you will have a strong idea of both concepts and its practical uses. Okay, next is the problem statement. Let's imagine a simple story. Okay, let's imagine a simple story. Asha is a data analyst at a fintech startup, has a big challenge, and her company wants to identify fraudulent transaction among millions of records. Excuse me. Her goal is to build a model that classifies every transaction. If it is fraud, we will be denoting it as 1. If it is not fraud, we will be denoting as 0, because a wrong prediction can either upset a customer or cause a huge financial loss. Next, we will see the prototype. Okay, so what can Asha do? She follow a design thinking approach. Okay, she is going to follow a design thinking approach. She empathize with the user, understanding what causes false algorithm. Okay, after empathizing, she is going to define what is the problem. She defines the problem and ideate possible solution and start experimenting. She uses algorithms like logistic regression, decision tree, or neural network, and her workflow goes like this. First, she will collect the data and pre-process it and select the future and model the training, and finally comes the prediction part. Now imagine if I divide you all into 3 groups. Okay, each group can discuss what feature you think are most useful for detecting fraud and why. That's exactly how data scientists brainstorm. Okay, next we will see about the common algorithms and concepts. Let's look at some commonly used algorithms. First one is logistic regression, a probabilistic approach. Next we will see about decision tree, which is a rule-based model, and random forest and an ensembling of multiple trees, and SVM, a margin-based approach. The whole process involves the data processing, splitting data into training and testing set, selecting the right algorithm, training the model, and finally evaluating. To check how good your model is, we use matrices like accuracy, precision recall, F1 score, and then conclusion. Okay, confusion matrix. For example, if missing a fraud is costlier than raising a false algorithm, we care more about recall than accuracy. Okay, using these matrices we can find out. Next is a case study. Let's do a quick case study. Okay, here let's suppose we have to predict whether an email is a spam. Spam is in the case 1 and not spam is, in this case, we will be denoting as 0. We can use features like sender, keywords, or even the mail length. This is a simple example of binary classification in real life. Your mail, Gmail or Outlook already does this every second. Next is application. Binary classification is everywhere. In healthcare, we can see it in healthcare. We can see it in marketing. In healthcare, it is used for diagnosing disease like whether a patient has diabetics or not. In marketing, it helps customer segmentation, who would like to buy or not. ready to buy. And in cybersecurity, it is used to detect intrusion or suspicious logins. And in HR, it is used to shortlist resume. It also connects with other fields like AI, NLP, and ethical AI, ensuring fairness in prediction. Pretty powerful, right? Next, we will be seeing a mind map. Here's a quick mind map to summarize everything we have discussed. It shows the end-to-end flow of binary classification work from data to decision tree. You can take a note of it. And next we will see here we will having an assessment and reflection. Let's wrap up with a few reflection question. Okay. How would you explain binary classification to a non-technical person? I'll give you a few questions. You can recall yourself. Okay. What factors would you consider before choosing a classification model? And here's a quick quiz. If false negative are more crucial than false positive, which matrices would you focus on? Already you have seen it is a recall matrix. Okay. Okay. Thank you. Next we'll conclude here. All right. That's all for the today's session on binary classification. I hope you enjoyed it and get some clarity on how this model works in the real world scenario. If you have query, you can contact me through this mail ID. Thank you.